In this section, I'm going to talk about the chain rule. One thing that needs to be known about the chain rule is that the chain rule actually applies to a lot of different classes of functions. But in this course, at least until we get to the exponential function, we're only going to apply it to powers. And so one of the rules that's a subset of the chain rules, the various chain rules, is the general power rule, which we'll talk about. But first, let me go ahead and try to explain to you how the chain rule works. Alright, so let's say that u is a function of x such that u equals g of x. Well, then the derivative of f of g of x, which would be actually also could be said to be f of u, is the derivative of f of g of x is actually f prime of g of x times g prime of x. Now, the shorthand notion for the chain rule is that if you wanted to take the derivative of f of u, that would be f prime of u times the derivative of u with respect to x, or an even shorter version would be f prime of u times u prime. Now, let me try to explain this to you using the chain rule, then I'll go ahead and go to the general power rule. So, let's say we had the function here, x cubed plus 5 raised to the 10th. Well, this is actually a composition of two functions. For one, you can say it's actually a composition of a function that raises another function to the power 10. So this is actually y equals u to the 10th, where u is x cubed plus 5. So what this rule means right here is if I took the derivative, in other words, this original function can be said to be a function of u, where u is x cubed plus 5. So if I wanted to take the derivative of this function, what I would do is I would take the derivative of u, the function u to the 10th. So take the derivative of u to the 10th with respect to u. Now, since I'm taking the derivative of u to the 10th with respect to u, that would simply be 10 u to the 9th using the power rule. But then I would have to take the derivative of u with respect to x. Well, u is this binomial x cubed plus 5. So I would multiply that by the derivative of x cubed plus 5 with respect to x. Well, when you put all that together, 10u to the 9th, remember u is just x cubed plus 5, so that would be 10 times x cubed plus 5 to the 9th, and then times the derivative of x cubed plus 5, which is 3x squared. And then you could simplify it further by multiplying the 10 and the 3x squared together and getting 30x squared times x cubed plus 5 to the 9th. And that's really as far as you could reasonably simplify it. Okay, well, actually it's probably easier to understand this if you think of it in terms of a power rule. Now we know that the simple power rule can be used on, like if you want to know the derivative of x to a power, that's n times x to the n minus 1. So for example, if you have y equals x to the 5th, the derivative of that would simply be 5x to the 4th. And of course you could use that power rule on other powers, you know, x to the 1/2 or x to the negative 3. But where you use the general power rule is where you have a function raised to a power. So instead of x to the 5th, we might have x squared minus 3 to the 5th. Or instead of x to the 1/2, we might have the quantity 3x minus 5 to the 1/2. Or instead of x to the negative 3, we might have the function x squared minus 3x plus 1 raised to the negative 3. So we know how to find the derivative of x to the 5th and x to the 1/2 using the simple power rule. Again, the derivative of x to the 5th is 5x to the 4th. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. But in order to use the general power rule, you actually have to invoke the chain rule where you take the derivative of u to the nth using the power rule, it's n times u to the n minus 1. But then you have to multiply by the derivative of u with respect to x. And let me show you that on these other two examples. So if I want to take the derivative of this function here, then I invoke the power rule like I did before, but it's going to be, I bring the 5 down, and then I have x squared minus 3, and I reduce the 5 to 4. So I have 5 times this to the 4th. But what I have to remember is I have to multiply by the derivative of the inside. In other words, the derivative of this function. So multiply by the derivative of x squared minus 3, and the derivative of x squared minus 3 is 2x. If I have 3x minus 5 to the 1/2, I take that derivative similar to how I took the derivative of x to the 1/2. That would be 1/2 3x minus 5 to the negative 1/2. But then I have to invoke the chain rule and multiply by the derivative of the inside. And the derivative of the inside of this is simply 3. Okay? So actually what you're doing here, literally what you're doing is you're actually taking the derivative of the outside. You're taking the derivative of the outside using the power rule, and then you're multiplying it times the derivative of the inside. Okay, so let's look at this outside-inside concept for a second. So here I have a trinomial raised to the negative 3 power. Well, I can think of that as u being raised to the negative 3, where u is simply the trinomial. So the derivative of the outside, if I take the derivative of the outside, that would be negative 3 u to the negative 4 using the power rule. But, you know, what is u? U is just this trinomial. So it's really negative 3 times that trinomial raised to the negative 4. Well, then I have to multiply by the derivative of the inside. What do I mean by that? Well, I have to get the derivative of this, the derivative of u. So the derivative of x squared minus 3x plus 1 is 2x minus 3. And when I put it together, I end up with minus 3 times x squared minus 3x plus 1 raised to the negative 4. That's the derivative of the outside, times 2x minus 3, the derivative of the inside. And then the last step here is just to simplify it so that you don't have negative exponents in your answer. Okay, so we can kind of speed this process up now that we understand this inside-outside concept. So if I wanted to take the derivative of x squared minus 2 to the 5th, I would think of the outside as being a function of u, where I have u to the 5th, where u, the inside, is simply x squared minus 2. So take the derivative of the outside, so I would actually use the power rule, so I'd have 5u to the 4th, but since u is x squared minus 2, that's the same as 5 times x squared minus 2 to the 4th. And then I multiply that by the derivative of the inside, which is the derivative of x squared minus 2, which is 2x. So putting it all together, I have 5 times x squared minus 2 to the 4th times the derivative of the inside, which is 2x. And then I can multiply 5 and 2x together and get 10x. And so I have 10x times x squared minus 2 to the 4th. Here's another one. If you have the square root of 3x minus 5, that's 3x minus 5 to the 1/2 power. So the outside concept, that would really just be u to the 1/2, where u is 3x minus 5. So if I take the derivative of the outside, I would have 1/2 3x minus 5 to the negative 1/2. And then I would multiply that by the derivative of the inside, the derivative of 3x minus 5. Now, what is the derivative of 3x minus 5? It's just 3. So I end up with 1/2 3x minus 5 to the negative 1/2 times 3. And then my final answer, I just write it without the negative exponent. Okay, here's another example. I have 3x squared minus 5x plus 1 to the 2/5. So the outside concept is that's just u to the 2/5, where u is the trinomial. Okay, so now taking the derivative of u to the 2/5, that would be 2/5 u, which is this trinomial, raised to the negative 3/5. and then multiply by the derivative of the trinomial. So that would be 2/5, 3x squared minus 5x plus 1 to the negative 3/5, and the derivative of the trinomial is 6x minus 5. And then the last step is to eliminate the negative exponent, and I get in the numerator 2 times 6x minus 5 over 5 times 3x squared minus 5x plus 1 to the 3/5. And, here's a couple more. This one can be rewritten as 3x to the 4th minus 5x to the negative 1/3, where the inside is simply 3x to the 4th minus 5x. So when I take the derivative of this, I bring the negative 1/3 down, and then I have multiplied by this expression to the negative 1/3 minus 1, which is negative 4/3, and then multiply by the derivative of the inside. And then when I put that together, I get the first factor, minus 1/3 times this to the negative 4/3, and then the derivative of the inside is 12x cubed minus 5. And then again, the next step is to eliminate the negative exponent. And one more here, I have this quotient raised to the 3rd power, so I would take the derivative of the outside by saying 3 times the quotient to the 2nd power, and then times the derivative of the inside, which would be the derivative of the quotient. But now to get the derivative of the quotient, it's a little more complicated. Since this is a quotient, I have to apply the quotient rule to get this derivative. So over here I applied the quotient rule. I take the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's the quotient rule. And then I simplify the numerator, and I got 1, and the denominator is 2 minus x quantity squared. So here is the first portion, 3 times that expression to the 2nd power, and then times the derivative of the inside, which turned out to be just 1 over 2 minus x quantity squared. Okay, let's do one more. Here we have a binomial to the 5th power times another binomial to the 4th power. Well, to apply the product, first of all, we got to think product rule. So how do we do product rule? I'm going to take the first function, which is x squared minus 3 to the 5th, and then times the derivative of the second. But when I do this second one, I've got to apply the general power rule. So the derivative of this would be 4 times 2x minus 3 to the 3rd, and then times the derivative of the inside, which is 2. And that's what students generally forget on a problem like this. And then the second term would be, I would take 2x minus 3 quantity to the 4th, which is the second factor, times the derivative of the first factor. Using the general power rule, that derivative would be 5 times x squared minus 3 to the 4th times the derivative of the inside. Okay, and now the rest of it's just algebra. When I multiplied 4 times 2, I got 8. When I multiplied 2x times 5, I got 10x. And then I went ahead and factored out, if you'll notice, in this term you have a common factor of x squared minus 3 to the 4th and 2x minus 3 to the 3rd. Also in this term you have the same common factor. And so if you factor that common factor out of the two terms, you're going to be left with the first term, x squared minus 3 times 8, and the second term, 2x minus 3 times 10x. And then I just simplified this as much as I could till I got it down to a trinomial. And then I also could factor a 2 out of this trinomial, and I put it out here, and then it left me with 2 times these 3 factors, x squared minus 3 to the 4th, 2x minus 3 cubed times 14x squared minus 15x minus 12. And then once I get it in that form, if I wanted the zeros, I could easily get the zeros of it. I'll let you freeze the video and work on this one a bit, and then when you're done, you can go ahead and restart the video and look at the rest of it. And then read my notes in red there. And then at the end, there's a summary of the rules that we've talked about thus far. So basically, those are all the rules that we've talked about in the course so far for derivatives.